Hi, we are going to simplify complex fractions. And this will make us feel like we're under a lot of water. But there's a way to come out alive. Believe me, if you just go one step at a time and depend on what you already know, and you know more than you think you know. So let's start off with a number fraction. Something right out of pre-algebra, 2/3 over 5/7. All that means is that the fraction 2/3 is going to be divided by the fraction 5/7. And when you divide a fraction by a fraction, you multiply the reciprocal of the second fraction. Then you multiply the numerators together, the tops, and you multiply the bottoms together, and you have it. Now let's put this together in a formula. If you have the fraction a over b, and that's in the numerator, and the denominator is c over d, then what you're doing is you're dividing a over b, by c over d, which means you're going to multiply a over b by the reciprocal of c over d, which is d over c. Then you multiply the two numerators together, and you multiply the two denominators together, and voila, you got it. Okay, here we go. We're going to add a fraction to a fraction, and then we're going to divide that sum by the difference of a fraction. In other words, we're adding two fractions on top, and we're dividing two fractions on the bottom. We're going to do this in two ways. The first thing we're going to do, the first method we're going to use, is where we get a separate common denominator for the numerator and for the denominator. That is, for the fractions in the numerator and the fractions in the denominator. So that in the numerator we have 5/4, and in the denominator we have -3/6. And then we reduce. And you know that 3/6 is 1/2. 3 will go into 3 one time, 3 will go into 6 two times. Now let's start on the left again, a little bit lower, and we'll have 5/4 divided by -1/2. But we'll have 5/4 times the reciprocal of -1/2, which is -2/1. Then we multiply the numerators together, we multiply the denominators together, and since the first fraction is positive and the second fraction is negative, we have a division. Now we're going to do it again. We're going to say 1/2 plus 3/4 over 1/6 minus 2/3, and we're going to find an LCD for all four fractions. So we're going to look at the denominators. We're going to look at 2 and 4 and 6 and 3. The smallest number all those will go into is 12. So I'm going to rewrite the fraction just the way it was. 1/2 plus 3/4 over 1/6 minus 2/3. But now I'm going to multiply the entire numerator by the LCD 12, and the entire denominator by the LCD 12. I'm really multiplying the whole fraction by 12 over 12, which is 1. So I'll multiply 12 over 1 times 1/2 plus 12 over 4 times 3/4. All of that over 12 over 1 times 1/6 minus 12 over 1 times 2/3. Now I multiply the two numerators in each of the 4 little multiplication problems. I multiply the numerators together and the denominators together. So I have 12 over 2 plus 36 over 4 over 12 times 1, which is 12 over 6, minus 24 over 3. And this will give me, well, let's see, 12 over 2 is 6, 36 over 4 is 9, 12 over 6 is 2, and 24 over 3 is 8. So starting on the left again, I'll have 15 over negative 6. And when I reduce that, I'll have 5 over negative 2, which is negative 5 over 2. Now we're going to work with some letters. We're going to do basically the same thing we did before. 1 over a plus 1 over b over 1 over a squared minus 1 over b squared. The LCD is going to be it's going to be a squared b squared, because if I look at all 4 denominators, the a goes into the a squared and the b goes into the b squared. So a squared times b squared is enough. I'll multiply a squared b squared times the numerator 1 over a plus 1 over b, and I'll multiply a squared b squared times the denominator 1 over a squared minus 1 over b squared. Now I will distribute. A squared b squared over 1 times 1 over a plus a squared b squared over 1 times 1 over b. Really should have put that over 1, but it's okay. A squared b squared over 1 times 1 over a squared minus a squared b squared over 1 times 1 over b squared. Now I cancel. This is called cross-canceling. I could have done it before, but I wanted to wait. The a squares cancel out, the b squares cancel out, and this is what we're left with. A times b squared plus a squared b over b squared minus a squared. Now I draw my fraction bar and I factor the top. by a greatest common factor. You never stop factoring. And I factor the bottom by the difference of two squares. The b plus a binomials cancel, leaving me with a times b over b minus a. And no canceling. That's a monomial on the top and a binomial on the bottom. Talk to you soon.